In this video, we're going to take a look at finding normal probability for a range, specifically when the range does not create a situation where you're looking at perfect or whole integer standard deviations from the mean. So we're going to look at how to use this or how to do this using a graphing calculator, specifically Desmos. Um, you can do this by hand. You can use a z-table and calculate z-scores, but we're going to take a look at how we can use technology. This is the type of problem we're going to be taking a look at. So x is a normally distributed random variable with a mean of 58 and a standard deviation of 5. What is the probability that x is between 56 and 60? And because of because of our standard deviation being 5 and the mean being 58, we can see that 56 and 60 are not equal deviations from the mean. Right? 58 plus 5 gives us 63. 58 minus 5 gives us 53. Those aren't the values that we have. So these are in between whole standard deviations from the mean. What we can do is, most graphing calculators have a function to figure out this probability. So in Desmos, just click the functions button. It'll start off on trig, but if you click distribution and then select normal distribution, you see it pops up and it's prompting us to enter the mean and the standard deviation. You could kind of zoom in on the graph and it gives you a normal looking curve, but as we change this, that's going to kind of flatten out and look different. So our mean is 58 and our standard deviation is 5. So put 58 comma 5 in the parentheses. And to find the cumulative probability, just click the checkbox, and right now you see it says equals 1, right? Because the area under the curve is 1. But if we put in our restrictions here, x is between 56 and 60, so a minimum value of 56 and a maximum value of 60, and it spits out that we would have a probability of 0.3108. And of course, this problem is asking us to round our decimal to the nearest thousandth, which is 3 places. So 0.1308. We're looking at that 8 to see should we round up or down, and so we're going to round up to 0.131. That would be our probability rounded to the nearest thousandth. One of the things that's great about this is you can move pretty quickly. So if we look at another one, x is normally distributed with a random variable, is a normally distributed random variable with a mean of 5 and a standard deviation of 24. We can just erase what we've got and put in the new information, right? A mean of 5, a standard deviation of 24. And we already had the box checked, so that popped up automatically in Desmos. But we still have our old values in here, so we need to get rid of those. And this is asking us what is the probability that x is between 8 and 10. So we would put min of 8, a max of 10, and there our probability 0.0327. We'd be looking at the 7 to round up, so we would say that this is 0.033 rounded to the nearest thousand. For this next example, we're going to look at finding a range that's greater than something as opposed to in between. So let's start this over from the beginning just so we can run through the whole process again. Our problem says x is a normally distributed random variable with a mean of 24 and a standard deviation 9. What is the probability that x is greater than 30? Write your answer as a decimal rounded to the nearest thousandth. One of the things we have to consider about this is we only have one value for our interval, right? Greater than 30. And so, in our minds, we've got to make the connection that 30 means, or greater than 30 means that we're going from 30 all the way to positive infinity. And so 30 would be the min, and positive infinity would be the maximum that we would need to enter to use that normal distribution function. And so when we jump over here, once again, in Desmos, we want to click Functions. We want to make sure we're on Distribution. Then we want to select Normal Distribution. Enter your mean 24 and the standard deviation of 9 with a comma in between, and then click Find Cumulative Probability. And so for this one, because we only had one value, we only need to put in the 30, and you see it tells us that the probability would be 0.252, and then we're looking at the 4, which tells us to round down. So we would leave it as 0.252, rounded to your nearest thousandth. So 0.252. If we have a less than, well, then it's just going to be switched. Instead of having a min, we're going to have a max, and then our minimum would be negative infinity. So let's take a look at an example where we have an interval less than some value. Basically, in this example, we have the same values for our mean and standard deviation. So in Desmos, we wouldn't need to change anything. We could just keep 24, 9. The change is that instead of it asking us for the probability greater than 30, it's asking us for the probability that x is less than 30. And so once again, in our mindset to just visualize that concept, we're talking about 30 and anything to the left of 30, right? Less than 30, which means our minimum is negative infinity and our maximum is going to be 30. So we'd leave the min alone and we would plug in 30 for the max, which all we have to do, since we've already got the mean and standard deviation in there, is delete our min, right? It'll automatically change to negative infinity. Enter 30 for your max. And we've got 0.747, and then the 5 would tell us to round that second 7 up to an 8. So over here we would say 0.758 would be the probability rounded to the nearest thousandth. Thanks for watching.